So we're going to continue to expand upon what we've been looking at with this marks array up to this point, and we're going to really go and see how we can actually handle it in code. But before we get to that, what I really wanted to do is point out exactly information about the data stored in the array. Now, if you look at the numbers here, we can see that they're all relatively the same type of data. In fact, that's actually a necessity. When we create an array, one of the rules is that all the data must be the exact same type. So that means there must be all integers or all bools or all doubles. You can't have some bool, maybe a couple strings in there and a byte or something like that. It doesn't work like that. They all must be the exact same data type. And not only that, they must actually be related. Now that's more of a guideline, but in reality, when we create our arrays, the point of creating those arrays is to store similar related data. So for example, all the marks of the students in a class. So going back to Visual Studio here, let's take a quick look. So what I've done here is I've created a mark, just an individual array called mark1. And you'll see that I've created it as type double. And the reason why I chose double is because we might end up with portions of a mark, say like 84.2 or something like that. So we just want to make sure that we can have high precision in our data. So what we're going to do now is we're going to expand upon this and see how we can do something similar with an array. So when we want to create an array, we need to specify what type is that array. So first of all, well, I want it to be double. Now I need to specify to C# that I'm actually creating an array of values, not just an individual variable. So to do this, we use these opening and closing square brackets. This tells C#, hey, I'm creating an array, so make sure you save enough space in memory for a whole array of data. And now, just like before, we need to specify an identifier. So it follows all the exact same identifier rules as all of our other variables from before, with one small change. Because we're holding a collection of data, we like to name our arrays using some type of pluralization. So for example, I'm going to be storing a collection of marks, so I will call this one marks. It's a pluralization of a single mark. Now normally when we want to create a variable, that's usually where we stop once we've set up the identifier. But arrays are a little bit different, they're a little bit more special, so we have to add a little bit more syntax. And the syntax goes like this: equals new, and now I'm going to specify the same data type as before, double, and I'm going to open up my square brackets and close it. And I'm just going to come back to this in just one second. Just want to explain what's going on here. This new really represents that we're creating a new entity. In this case, this entity is an array. This double just is reinforcing the fact that we are creating an array of doubles. And now these square brackets here, we've already specified that it is an array. What we're doing here, inside these square brackets, this is where we get to specify the size of the array, the length of the array, how many items or how many elements are stored in the array. So if we go back to our program here, or our notes, we see that we have 5 elements, numbered from 0 to 4. So what I want to do is I want to specify the number of elements that are going to be stored in this array. This allows C# to store or to reserve the proper amount of space in memory. So in this case, we want to put the value 5. Very careful. I'm not putting the maximum index, which is 4. I'm actually putting the total number of elements, which is 5. So what I've done here is I've essentially created an array of type double with the name marks, and it stores 5 elements. So if I were to normally, let's say for example, give mark1 a value, I could say mark1 is equal to 90. Simple. Now if I wanted to display that mark, I could do something like console.writeLine, let's say mark 1. Fine, no problem. If we run our program, oops, if we run our program, we should get the value 90 show up on the screen, which we do. Now how do we do the same thing for an array? Well, if you remember from our analogy here with the pizza, we have to specify two things. We need to specify the street and the street number, or in our case, the array and the index. So let's say, for example, I want to store the value 90 in the first index of the array. Well, the first index, what number is the first index? Well, it's 0. So when I want to do this, it's going to follow the exact same code that we did before, marks, but now I need to specify that index. I do that using the square brackets again. So I am going to store a value in index 0 of the marks array, and the value I'm going to store is 90. And it works the exact same way if I want to display that data, because all I'm really doing is saying access this specific element of this array and retrieve that data. So I'm just going to copy and paste this because I'm a lazy man, and instead of mark, we're going to put marks bracket 0. Now if we run our program now, we should end up with 90 showing up twice on the screen. And we do. And what we can see here is we can continue on this path specifying all the values for an array. Just going back, we see we have 84, 63, 74, 81. So we have 84, 63, 74, and 81. And now I need to make sure that I change all these index values to be the correct ones. So index 1, index 2, index 3, and index 4. So now I've stored all of that data in a single variable. So no matter what I want to put out here, let's say I want to put out the value of index 3, and we run our program, and we get 74. Looking back at our code, we see that at index 3, we did indeed store the value 74. So this allows us to access each individual element, both to store as well as retrieve that data.